Everyone, this video is going to show you how to conduct a correlation calculation in SPSS. So the first thing that you're going to need to do is to create a scatter plot to make sure that the two variables actually have a linear relationship. So to do that, you'll go to Graphs, Legacy Dialogues, and Scatter Dot. You'll select Simple Scatter and say Define. You're going to put your two variables in here. It doesn't matter which goes on the y and which goes on the x. Remember that for a correlation, you need two continuous or interval variables. I like to put a line in my graphs. So once you get your output, I can look at this and see that there's a pretty serious linear relationship here. But if I want to see exactly where that line falls, I'll come to the chart editor. So I double clicked on that chart and it gives me the chart editor. Then I'll go to Elements and Fit Line at Total. You'll make sure that linear is checked here. I don't like to have the label put on there. The label tells you what the line's equation is. I don't like that on there. So then you'll push Apply, Close, and then when you close this window, you can see the linear relationship there, and it's actually going to give you your r squared here as well. So that gives you your linear relationship. So once you confirm that a linear relationship is in fact present, then you can proceed to doing the correlation calculations. So to do that, you'll go to Analyze, Correlate, Bivariate, and then you're going to put your two variables in here, your independent and your dependent variables here. Actually, hold on, I'm sorry, I skipped a step. So before you do that, you've got to see if your data are normally distributed, so if you know if you're using Pearson or Spearman. So to do that, you'll go to Analyze, Descriptive Statistics, and Frequencies. You're going to put your two variables in here. Go to Statistics, get the skewness and kurtosis. Don't display the frequency tables, make sure that's unchecked, and push OK. So it's going to give you your skewness and kurtosis tables there. You'll want to take them and put that into the skewness and kurtosis calculator. I've already done that, so you can see 0.028, 0.071, I put here, 0.142 and 0.142 I put here. All of these are within the range of normality, so I'll be using Pearson. However, if you did this and you had more than half of your variables come out with non-normally distributed, not within -3 to +3, then you would choose to use Spearman. So, all right, back to our correlation calculations. You'll need to report those skewness and kurtosis levels in your write-up. So now we're going to get back to calculating the correlation. So you'll go to Analyze, Correlate, Bivariate, and you'll put your two variables in here. You're going to check the Pearson or the Spearman, whichever one is correct for you. So I would be doing Pearson here because my data are normally distributed. But if your data are not normally distributed, you would check Spearman. I am going to check Spearman here just so I can show you what that table looks like, but that would not be the appropriate statistic to use for this. You're going to leave the tested significance two-tailed and flag significant correlations. So you're going to push OK. So you'll see this is the Pearson table. So we're going to look at that one first. So that is the correct statistic for these data. So you're going to want to look at this table, and I'm going to show you what that looks like over here. So in order to write your numerical sentence, you'll need a few different values off this table. So it actually looks like there are 4 cells here. That actually isn't, you're not going to use all 4 of them. You're going to use this one where your independent variable lines up with your dependent variable, or your two different variables line up. So you'll need your N, which in this case is 1180. That's how many cases you have, 1180. Then you'll need your correlation coefficient, which is right here in this line where it says Pearson correlation, 0.664. You only need to report it to the first 2 places. So in this case, we don't round up because of the 4. And then you'll need your p-value. In this case, it's 0.000, so we say less than 0.001. The next thing you'll do is to actually calculate the degree of variance. How much do these variables overlap? In order to do that, you'll need to square the R value, which is actually right here. So when you square that just using a regular old calculator, for this one it comes out to be 0.4409, and so we can say that about 44% of the variance in these two variables overlap. So that's how you do a Pearson correlation. Now, if you were doing a Spearman correlation, you're going to actually go to this table and do the exact same thing. So your R value would be here. You can see that the R value is just slightly lower here. So 0.624 instead of 0.664. So there's not a ton of difference, but because this calculates the correlation just a little bit differently, they don't always match. So this would be the table you're using if you had non-normally distributed data. The other thing that you need to know is that there are different cut levels, and these are written in the instructions, in the written instructions that are attached in Blackboard. So there are different R value levels that say whether this is a small correlation, a moderate correlation, or a large correlation. So I want you to go look at that. For this is a large correlation with a fairly good degree of overlap between the two variables. So you'll need to be able to interpret that and write about that in your write-up. As always, if you have questions, give me an email. Bye.